Hey guys, my name is Moses and this is Programming Learning Channel. This channel is dedicated to programming and here I will do series on different types of programming methods, and today in this video we will see about terms related to ladder diagram, conditions for building ladder diagram, and about normally open contact. Okay, let's begin. In my previous video, we saw about PLC, its programming methods, and how to download and install WPLSoft. And now let's start this video with terms related to ladder diagram. Okay, here what you see is the ladder diagram shown in WPLSoft, but the actual ladder diagram looks like this. The ladder diagram has two vertical lines and multiple horizontal lines. The two vertical lines are called as rails, and rails are of two types: positive rail and negative rail. Here the power flows from positive rail to the negative rail, and the horizontal lines in the ladder diagram are called as rungs, and these rungs provides the path for the signal to flow between the rails, and on these rungs all the inputs and outputs are placed. So arranging these horizontal and vertical lines together forms a ladder diagram. Now to see how ladder diagram works, let me take an example of this circuit. In this circuit we have a battery as a power supply, an input switch and an output bulb. Now let's start the process and see how the circuit works. Let's actuate the switch to allow the power to flow through it, and the output bulb switches on when the power supply flows through it, and now the circuit is completed. Now after seeing how this circuit works, let's place both the circuit and the ladder diagram next to each other. So as you can see, the working process of both ladder diagram and the circuit is same, and both in their setup have a power source, an input and an output, and a path that connects everything. Therefore, learning ladder diagram is very simple when compared to any other programming method, as it does not use any complex statements or any fixed syntax. Instead, it has an easy to understand graphical way of programming, which is better than any other programming method. That's why ladder diagram is so popular. Now let's see about the input contacts used in ladder diagram. These are the input contacts commonly used in ladder diagram. This is normally open contact, this is normally closed contact, this is rising edge triggering switch, and this is falling edge triggering switch. In this video we will see about normally open contact, and this is the option to get normally open contact in WPLSoft. Okay, here you can change the device name and device number, and this is the range of the device number. Here we can add the comments of the contact, and now after doing all this, let's press OK. Okay, this is the normally open contact, and the function of this normally open contact is similar to a switch. That is, this will block the path for the signal until it is actuated just like a switch. So this is how a normally open contact works. And before we continue, if you have understood the video so far, then please like the video. And if you like the video, then share it with your friends. And if you have any doubts, then write them in the comments. And if you want to see more videos from this channel, then please subscribe to the channel and press the bell icon. Okay, now let's continue with the video. Now let's see about conditions for building ladder diagram. There are few conditions to be followed while building a ladder diagram. Among those conditions, the first condition is inputs can be connected in parallel and in series to form connection, but outputs can only be connected parallelly to form connection. To learn the meaning of this condition, let's look at this program. Here I have connected x0 and x1 parallelly and x0 and x2 in series. And for output, I have connected y0 and y1 parallelly. Here I have connected both the inputs and the outputs according to the condition, and we didn't face any error or any difficulty doing it. Now let's see if we can connect an output in series with the output y0. Okay, let me take output y2 and I'll place it in series with y0. So as you can see here, the output y2 replaced the output y0 instead of getting connected to it in series. So in this way, the first condition is justified. Now let's see the second condition. In a program, inputs can be used multiple times as input, but an output should not be used multiple times as an output. To learn the meaning of this condition, let's look at this program. Here I have taken x0 and output y2 twice, one in both the rungs, and input x1 in second rung. Now let's activate X0 and see what happens. As expected, the output is not switching on, and this is because of the input X0 in the second rung. Even when the input X0 is directly connected to Y2, the output is still waiting for the input X1 to get actuated. This is why in the condition it is mentioned as outputs should not be used multiple times instead of outputs cannot be used multiple times, because in the first condition we were not able to connect two outputs in series, but here we can actually use outputs multiple times and even the software does not show any error, and this is the most common mistakes done by the beginners. Okay, now after the second condition, let's see the third condition. The third condition says that an input cannot be used as an output, but an output can be used as an input. To learn the meaning of this condition, let's look at this program. Here in this program, I have used X0 and X1 as inputs and Y3 and Y4 as output. Now to test the condition, I will change the output Y3 and replace it with the input X0. Okay, as mentioned in the condition, we are not able to use input as an output, and it's logically right because, for example, we can never use a switch as an output because its only purpose is to allow the current to flow through it when it is actuated. Now to check the second half of the condition, let's replace X0 with output Y3. So as you can see, the second half of the condition is verified, and to explain this, let's use the circuit. Here we have a bulb which is an output, and as we know, bulb produces both light and heat. Light is good, but the heat produced by the bulb is not good. So to avoid that, we may provide a cooling system which gets actuated when the bulb produces more heat. So in this way, the bulb acts as an output by producing light and as an input for the cooling system to reduce the heat. By this, we conclude conditions related to ladder diagram. Okay, now we have come to the end of this video. In the next video, we will see about latching operation using normally open contact, examples of logic gates using normally open contact, and about normally closed contact. Okay, this is it for today's video. Until next video, stay cool, calm and confident, and stay subscribed. Thank you.